There we go. Today we're going to talk about software-defined networking. And hopefully my slides will advance. Before we get started, the obligatory legal disclaimer. I'll give you all a chance to read this. There will be a quiz on this at the end. There we go. Hopefully you all had a chance to read the legal disclaimer. Here we are in the world of rapid application development, massive virtualization, hybrid cloud computing, and our networks are in the way. Designing, deploying, changing networks to meet changing business needs is still mostly a manual and sometimes a painful process. I hope your own network isn't quite as painful as this chap's, but the point is, it isn't working. The network is in the way. We need a new model. So here's a bold prediction that new models can have something to do with a technology called software-defined networking. All right, perhaps that wasn't such a bold prediction. I don't seem to be able to open my browser without seeing another headline about SDN. Now, granted, I should probably change my homepage, but that wouldn't change the reality that you can't take a step these days without stumbling over another article or another announcement about SDN. So what is software-defined networking? Well, Ivan Pepeljack, I hope I'm pronouncing his name correctly, defines it as programmable networks, or more precisely, network elements that have been configured through a reasonable and documented API. I don't think that definition is quite sufficient, though. The Open Networking Foundation goes on, and they say that software-defined networking is an emerging network architecture where network control is decoupled from forwarding and is directly programmable. Well, we're getting closer. I'm still not sure that's a complete definition, but we do know that software-defined networking includes programmability and the decoupling of the control plane from the forwarding plane. The point is to allow programmatic control over the network infrastructure. Now, a few things that software-defined networking isn't. It's not a substitute for smart network design. If anything, the expectations on networking engineers and architects is higher than ever before, and network architects are going to have to get a lot closer to the application guys to meet those expectations. And software-defined networking is going to help you get to that point. It's also not just about OpenFlow. OpenFlow is an important element of it, but not the only element of software-defined networking. So we see that software-defined networking is all about network programmability, and that is having a standard open set of APIs that allow you to interact between network elements. And I don't have the word open on the screen, but it's an important part of this. It's about a separation of the control plane and the forwarding plane, and this is important in allowing programmability of your network. So the forwarding plane can be hardware-based traditional routers or switches, or it can be software-based routing and switching. The control plane needs to be agnostic to the underlying networking device, not just networking hardware, but also networking software. Software-defined networking is also about integration with higher-order orchestration platforms like OpenStack, CloudStack, vCloud Director, and whatever it is that Microsoft's going to be coming out with. It's about vendor independence. But maybe most importantly, it's about a network topology and orchestration that's derived from the application of the tenant. And this is how SDN is different from other switch networks or traditional switch networks. So what's driving SDN? Well, a lot of people say agility, and yes, there are companies out there that want and need more agile networks, but I don't believe that's really the driving factor here. Others say it's about delivery of new services, which is probably another way of saying agility, but once again, important but not the driving motivation behind SDN. SDN is really about the economics of networking. It's about the extraordinary capital costs of building networks today and the despair that many network administrators feel at paying the Cisco tax every time they want to add or change the network. It's about the escalating energy costs, rising real estate costs for the data centers, and more than anything else, it's about the extraordinary rise in operating costs as network administrators scramble to make their networks more responsive to their business needs. So if we look at at today's traditional network, it's a set of monolithic hardware-based networking devices, routers and switches, each with its own control plane and forwarding plane. By design, each of these network devices only knows its immediate neighborhood. Sure, routing protocols such as BGP and OSPF provide some route cost information that allows each device to choose the least cost path. But the least cost path isn't necessarily the optimal path. And those routing tables don't know anything about the changing value of different application or tenants or changing business conditions. What this model lacks are an end-to-end awareness of the network, an overarching view of what business needs are. It lacks programmability in any kind of central and easily accessed manner. And it lacks the ability to dynamically change in an intelligent way. What I'm saying is that there's no higher level abstraction layer. And that's what SDN is about. So if we look at the SDN model, each device becomes a forwarding device, each controlled by a standard open set of APIs. The network device can be hardware-based, a hardware-based switch or router, or a software networking device, which is a terminology that's going to be known as network functions virtualization. The control plane has been abstracted from the networking device. It's now an application, probably running as a virtual machine or on an x86 server. And the control plane, in turn, has a standard set of APIs that allow it to derive intelligence from applications and to be managed or orchestrated by software. The control plane provides a high-level abstraction layer that represents the entire network as a service. Networking is an on-demand programmable resource. Now, no one vendor is going to be able to provide this entire model. Instead, we're going to have to be thinking about an ecosystem of SDN products that are designed to work together. I don't know why Nasira is out there by itself, a little problem with my PowerPoint, but that ecosystem is going to include standard networking elements, routers and switches and virtualized data centers. It's going to include tunnel and overlay technologies to allow you to extend and flatten the network as necessary, including technologies such as VXLAN, NVGRE, and STT. It's going to include a rich array of different controllers, including, technology like Floodlight or Nasira, other route control and security control technologies, and some open source ones that I think we're still going to be hearing more about over the coming months. And finally, it's going to include an orchestration, monitoring, and management layer coming from any number of different sources. And these, in turn, are going to be able to have interactions to a common set of APIs with applications that will derive the business value that will direct the network and how it has to change. How is SDN being used today? Well, in a few cases, we're seeing carrier-grade open flow-based networks being developed. We see some beginning of enterprises thinking about network virtualization and building SDN networks within highly virtualized data centers, but mostly we're seeing SDN in research environments. And frankly, that's not going to change anytime soon. This isn't an SDN revolution. This is a networking evolution, and it's going to take years before mainstream networks are being run around SDN principles. So why is SDN important? Well, because data center networking technologies are changing, or they need to change. And they're changing because of a vast increase in virtualization in the data center is leading to far greater server density. And when you have greater server density, you have greater traffic density. It's because of changes in traffic flows. It used to be that the majority of traffic flowing to and from a corporation or an organization was north and south. Now most of that traffic is east-west, running between servers, sometimes between VMs within a hypervisor. It's because the capital cost of infrastructure needs to decrease and the operating costs of running that infrastructure, and it's because NetOps needs to be able to keep pace with DevOps and the ever-increasing speed of new application development. It's about the economics of networking. So where are the savings? Brocade commissioned a total cost of ownership study through ACG Research, and we've got a link there that I'm sure you can't read in that tiny font telling you where to get the research. If you're interested in seeing the total cost of ownership study, contact me after the presentation and I'll get you a link. Essentially what they did is they looked at 3 different applications of SDN and tried to estimate what kind of savings companies are likely to see, or organizations. And that included an application of service creation and insertion, WAN virtualization, and network analytics. And the bottom line is that they were seeing total cost of ownership gains and from network and reduced capital expenses of anywhere from 13 to 39%, reductions in operating costs from anywhere from about 18 to about 32%. Labor costs are down significantly. The total cost of ownership seeing benefits anywhere from 48% to 83%. So clearly there are dramatic savings to be had through software-defined networking, and that's savings in operational savings and capital savings, and that doesn't really try to quantify the savings or increased revenue from improved agility, improved uptime, better management, and better planning. So if we take a look at early SDN deployments, what we see is typically vSwitches running on a hypervisor. Those vSwitches could be open vSwitch, or they could be proprietary switching solutions controlled through a central controller, connecting layer 2 segments using VLANs or some emerging layer 2 encapsulation technologies. The controller allows connection of virtual machines to layer 2 networks in a pretty flexible way, allowing for fully segmented, isolated networks to share hardware. What's not addressed here is how to connect these new networks to the networks of today, or to each other. That is, how to go between these islands of SDN and to connect seamlessly with legacy networks. That's where Vyatta comes in. Vyatta provides software-based networking solutions that uses protocols that you know well, such as BGP and OSPF, to connect existing networks, and that provide routed hops between those layer 2 segments. Vyatta includes stateful firewall, so you can securely transition between networks without violating security policies. Because Vyatta is software, architects can put this networking elements anywhere in the network. And as a software solution, Vyatta can be deployed as needed and can scale easily. If you need to move a Vyatta image, you can do that. If you need to shut down a router or network segment, you can do that without the sunk costs, operational costs that are required as part of proprietary and dedicated hardware solutions. So what does Vyatta do? Vyatta delivers network function virtualization. That is, networking functions in software. Okay. In a network function virtualization context, it allows true virtualization of the network. Now, that's a term that's been used for a long time. We've been virtualizing our servers for the past decade, and the majority of organizations are well on their way to virtualizing large parts of the data center. But the networking layers remain dedicated to hardware. With Vyatta, you can remove those networking elements and install them as virtual machines within your hypervisors, allowing you to virtualize not just servers, but the entire network. In fact, some customers have gone so far that they're creating entire software-defined data centers, where they're virtualizing, say, an entire 30,000-foot data center with separate tiers for web, application development, storage networks, backup management networks, all being templatized, all turned into one virtualized environment, and able to roll out new data centers on demand. Now, that's true multi-tenancy. Vyatta offers advanced routing, stateful firewall, and extensive VPN options. Who are we? We're the leader in software networking. We were founded in 2006 in the belief that the future of networking is in software. We were acquired by Brocade just a few months ago. Vyatta is used in thousands of production networks. We've had over 1 million downloads, and Vyatta is now proudly a Brocade company. A second slide on who's Vyatta. So for anything I didn't cover on the previous slide, we're a Silicon Valley company selling software solutions since 2006. We are open source based. You can install us as virtual machines. You can install us in any major hypervisor. We're agnostic to the hypervisor. You can install us in any of the major clouds. You can install us on standard x86 devices, since we are essentially a Linux-derived technology. We offer routing, firewall, and VPN, an open architecture with RESTful APIs that will allow interaction with major new orchestration technologies, and we support open standards and advanced routing protocols. The highlights of the technology, I'm not going to read this entire slide, but it's a deep, rich platform that provides extensive Layer 2 and Layer 3 networking services in a factory that you're going to find very easy to swallow. It's also delivered as a service, or you can purchase it on an as-needed basis. So remember when you used to get excited about networking? It's that time again. I hope you've been excited about this webinar as well. Now would be an excellent time to open up the presentation to questions. And let's see if we have any questions here. All right, I see I have one question from Mike. He is typing. He's asking what hypervisors we support. Vyatta supports all major hypervisors. So yes, we run on ESX, KVM, Xen, Hyper-V versions 2008, 2012. So here's another question asking for the difference between the open source and the paid version of the product. Vyatta has supported by a strong open source community. You can go to vyatta.org and see the community. There's a lot of self-support, a lot of community-derived technology there. However, the paid version of it does have some additional functionality, including graphical user interface, RESTful APIs, added authentication technologies, and more to come. There is a more detailed list comparing the free and the subscription versions of it on vyatta.com. David has a question here. Let me scroll to the top of it. I have a very small screen for seeing these. Well, this is almost impossible to read. Let's see if I can move this screen over here. So David said, when you stated you can use your Vyatta with existing physical networks, can we use Vyatta with our existing Cisco networking equipment? Yes, that is to say that if you were establishing a data center to connect to VPN, you could have Cisco on one side and Vyatta on the other side. I hope that's the question you're asking. Vyatta won't run on the Cisco networking gear. Instead, we will run as a virtual machine with a hypervisor, or you can install us directly in bare metal on an x86 server, install a couple of NICs in it. You can turn that server into a very highly functional router and switch. All right. I don't see any of the questions. I'll give you guys just a couple more minutes. A recording of this webinar will be made available. You receive an email tomorrow, I think, that will give you access to the recorded link. I appreciate you all joining us today. We've got a number of additional webinars that we'll be sponsoring, so come back to vyatta.com to see those additional webinars. I hope you join us. If there are any topics that you'd like to see us cover in the future, send a note back to me at dan@vyatta.com, and I'll see if we can accommodate you. Once again, I appreciate everyone joining us here today. And with that, I think we will end today's webinar session. Thank you for joining us.